Okay, so this is the warm-up question to do with motion in one dimension. So first strategy in any physics problem is visualize the problem. If you just look at the abstract text, it will not give you ideas. Many times I have found that if you visualize the problem in the diagram, it opens your mind to new ideas. So how will you visualize this? He goes from school to house. So let us say this is the school, and he goes to the house. Let us say this is the house. So he goes from school to house at 30 meters per second. And when you visualize it using a diagram, put all the data of the question in the diagram. Okay. See, our brain is just like a computer. RAM, it has a random access memory which is limited, which is where the information which needs to be processed is stored temporarily. And then you process it, and then once it goes to the hard disk, that is your long-term memory. Okay. So when you solve a problem, you need all the information in your RAM, the random access memory, which is limited. So if you put all that information in the diagram in one place where you can see clearly with all the connection between it, you are freeing up your random access memory, your RAM. So you can focus on solving the problem rather than storing the information, because information is right in front of you. Okay. So 30 meters per second. Then, and from school, so let us, he goes from school to house and comes back to school from home. So this is school, this is house, and he comes back to school from house at 20 meters per second. What is his average speed? So this is the given, and what do you have to find? V average. Okay. So now every problem is usually of this sort. It's like you are standing on stones and the river is there, and again some stones are there. And solving a problem is like trying to jump from these stones across the river and landing on these stones. Okay. So these stones are the given data. And this is finding the unknown. And what will take you from here to there? The relation between them. There is a relation between the given data and the unknown quantities. So you need to figure out what is the relation. Using the relation, you can easily make the jump from the known to the unknown. Okay? So now, unknown is here, so the average is here. Known is the V1 and V2. So what relation do you think exists between the known and the unknown? Come on, make a guess. Yes. Okay, V1 plus V2 by 2. That is the trap. So you fell here and crocodile is right here. Because you use the wrong relation. Average velocity, when did I teach you that it is the sum of, it's the mathematical average of velocities which were used? Did I ever say that? Suppose you go at 10 meters per second, then 20 meters per second, then 100 meters per second, then 1000 meters per second for 2 seconds. Will your average speed be this mathematical average of these? So you have used the wrong concept at the wrong place. Mathematical average is not the average velocity. So go back to the definition of the unknown quantity. What is this defined as?
Total distance.
Total, you said total displacement. In this case, it will be total distance only. Okay, because displacement will be 0, no? So, okay, I have asked you about average speed only. Okay, fine. So you are right. If it was average velocity, what would be the answer? 0. Because average velocity will be total displacement by total time. So it will be 0. But I have asked average speed. So total distance by total time. So total distance by total time. Now, how do we progress? So, from this side, we have started building the bridge to the given data. We have found out that we need to find out what is total distance and total time. So, what is the total distance?
Distance is 2x.
Very good. So, that is the next trick. If you don't know something, give it a name, a variable name, and then set up the equation and you can solve for it. That's the simple strategy. Unless you give a name to something, you can't use that quantity in your calculations. The name is the handle to control that quantity, manipulate that quantity. So, let the distance between school and home be D. So, total distance would be how much? 2D. And total time?
Again, we give it a variable.
So here you need to be careful. If you keep giving names to everything unknown, you will be having to solve for too many equations. Always remember number of equations which are required. Number of equations required will be equal to number of variables, or let us say number of unknown variables. Because you will be solving a system of linear equations, right?
Yeah.
So if you keep adding too many unknown variables, you will have that many extra equations to solve. Yes?
So can we be upon the moment?
Yes. So now what we will do is to find the time in each journey, we will use this speed relation. Speed is distance by time taken. So let us do it. So this is S and this is H. So we will do it for two cases, from S to H and from H to S. School to home and home to school. So you can use this simple visual way of using the speed is distance by time. So D, V, T. Here also D, V, T. This basically speed is distance by time. Time is distance by speed. Distance is speed into time. It's a visual way of doing it. So now what we know, for school to home the distance is V. Agreed? And what is the speed from school to home? From school to home, what is the speed? 30 meters per second. So now initially what we will do is we will solve it algebraically in general terms, in a general variable method. Finally we will substitute the values so that we get a general formula. So let us call this V1 and let us call this V2. Okay? So I am going into V1 and what is the time taken? Distance by speed. So it will be D by V1. And similarly here, while returning also the distance is D, speed is V2, so time will be D by V2. So now can you substitute here what is total time?
Yeah, you can add one.
So what will it be? What should I write? This time plus this time is total time. So what should I write?
So
V by V1 plus D by V2, right? Agreed?
yeah.
So now D is common in both numerator and denominator. So it will become 2 divided by 1 by V1 plus 1 by V2. Agreed?
Yeah.
D into 1 by V1 plus 1 by V2, D will cancel out. Here?
Does it work like that?
Huh?
Yes, okay. Now how could you cancel out the V?
Okay, let me do it step by step. 2D divided by D into 1 by V1 plus 1 by V2. This step is clear?
Yeah.
I just took D common. Clear?
Yeah.
Now I can cancel it. D1 by D, D1 by D. So this will become V1 plus V2 by V1 V2. So this is the formula. Agreed? Now you can substitute. So 2 into V1 is 30, V2 is 20 by by 30 plus 20. So what do you get? Huh? Writing correctly? Something I mean wrong.
Is that 600?
Yeah. 3 2s are 6. 0 0 5 1s are 5.
Sir, like 12, 24 होना चाहिए. आपने काटा गलत है. 24 होगा सर. 24. 12.
Oh. No, 24 is fine, but is 24 correct? Oh yeah, 24 is correct. The velocities we use are 20 and 30, right? So it won't be the exact average of 20 and 30, which is 25. It's something different from the average. That's what I remember. So I forgot that we were using 20 and 30, and I was thinking we were using something else. Okay. So it's correct? So it's not equal to the average of the two. Average of 20 and 30 would have given us 25. Instead it's 24. Got it? Clear? Everyone? Understood? So this was the warm-up question. So this is how you apply knowledge to solve new problems. Now let's derive this fourth equation of motion. Can you try it? You can see the strategy for deriving this is very simple. Please try it on your own. Anna, try to derive this fourth equation of motion on your own.
Derive it.
Yeah. So I'll tell you the steps. Which quantity is missing in this?
So is it b square equal to u square plus 2as?
S is same as x. S is displacement.
Time is
X is also displacement. What is missing? Time.
b square minus b square upon t.
So time is missing. So what you do is take this and write it as t equal to something.
B minus
Okay.
u upon a.
Okay, so v minus u upon a. Now substitute that in this. These three we have already derived in the last class. So once you have derived the result, you can use it for proving other things. So substitute for t here. You will end up with this. Do it. Before I do, please do it in your notebook. Get some practice of doing things on your own. Amman,
Please take my pen.
take one more pen then. Borrow it from the lab assistant. Hurry up. Derive this. Ariman. Let me see who finishes it first.
So the methods which we used to find it earlier was different.
Yeah.
You showed us the
The
graph.
first three we derived using the graph. But for this one, we don't need to use a graph because it can be derived using the first two. The first and third equation. It is just an algebraic manipulation. So now again you are doing flex.
So I got u square plus 2a. What's the next second best thing?
Did you get this equation?
I didn't get the x at the last. What's that?
S and S.
You are substituting this in this. Got it?
Got it.
Yes, I got it.
Good. Good enough. Try it. I will anyway do it on the board. You can check your work.
You do u plus v upon 2 into v minus 2 upon a.
Now wait. See. So if you substitute this in this, you get x equals v plus u upon 2. U plus v upon 2 plus v plus u upon 2 into t is
That becomes
v minus u upon
v square minus u square.
a. So v plus u into v minus u is
V square minus u square.
v square minus u square
By 2a.
upon 2a.
Then 2ax. and
So you get v square minus u square equals 2ax. So v square equals u square plus 2ax. Okay, now Rishabh, what is x? No, this this whole thing is equation one dimension. So we are talking about displacement, not distance. So is x position? No. X is displacement. There is a difference between position and displacement. Okay, let us ask you a question. I did it last class also to make you understand that x is not position, it is displacement. Okay, do this question. Yeah, of course. Yeah, do it. Do it and tell me how you are doing it. So we have derived the four equations of motion. I have given you. So this was a fourth stage. Now we have done a stretch part. Okay, first reflex. Do it individually first.
So, you don't know the direction. You don't know the direction.
It's one dimension motion. No, he will travel only in one direction.
Yeah, but towards the pole or away from?
Away from the pole. Right? Is anyone there who doesn't know how to start?
So this is using the last equation, yeah?
Huh?
Using the last equation.
Yeah. Use this. Shiva? Try it, please. Keep the back down. Back down.
So first defining acceleration.
So what is x? So,
Acceleration is already given, right?
so
Yeah.
what is x?
You tell me. Are you asking what is x in this equation?
So acceleration is not given, it's given.
I thought you know it is supposed to be displacement, not position. Displacement is change in position, which is final position minus initial position. Okay? When we derived it, this was supposed to be displacement. You start from initial position, you end up in the final position. The length of the straight line joining the initial position to the final position, that length is displacement.
X is displacement.
Yes. Whereas position is either initial or final. So the difference between initial position and final position is displacement. So initial position plus displacement will give you final position. What?
S is displacement.
Listen,
X
X
is
is displacement, V is velocity. Okay, I'll tell you the steps to be followed. Step 1 is, okay, you want to try? Step 1 is first draw a diagram and put all the data in the diagram. Rahul, are you trying? Try it. Draw a diagram and put all the data in the diagram. Okay. Do it, everyone. Acceleration is final velocity minus initial velocity by time
V
delta.
is final and U is initial.
Yes. Keshav, I thought you would tell the answer first.
So you don't even what's the time taken?
You don't need time, no? See this equation, it doesn't have time.
Acceleration. How do you find acceleration without time?
Acceleration is given in the question.
Where 20?
Then he travelled at 5 meter per second square. What does it mean? What has the meter per second square?
Acceleration.
Why are two laptops open? They're not supposed to be open.
Asking calculator.
No need. You borrow a scientific calculator. No. Take the calculator from the lab assistant. Because I can't check from here when you get distracted. You people are victims of laptop addiction. It's not about trust. You are helpless against the charms of the laptop.
So,
Then do what?
Charms.
अरे सर
हाँ.
2x में a तो नहीं पता x पता है हमें.
A पता है भाई.
A
X निकालना है भाई.
Acceleration is given in the question. That's what I'm trying to tell you. Meter per second square is unit of power.
So I'm doing one calculation. Right?
So is the final answer?
Go and get the calculator. आने बढ़.
So is the final answer?
Done.
Meters to the pole.
So the
No, final answer I don't know. Unless I solve it, I also don't know. But first tell me the method.
You just substitute everything, then you make x the subject and you solve it.
So then tell me what you do. So okay, we'll do one thing. I will do it on the board now since you all had enough time to try it. Then check your answer in mind. Okay. Okay. So first step is visualization. So this is the path along which he travels. This is the lamp post, and he is 10 meters from it. Okay. Then he traveled at 5 meters per second square. This is his acceleration. Away from the pole till he reaches speed of, and he was standing initially, so u is 0 meter per second. He was standing, he was at rest. So then, when he reached here, his speed is v, which is 20 meter per second. What is his new position? So this is the final position xf, this is the initial position xi, and xi is 10, we need to find xf. So change in position is x. X is final position minus initial position, which is xf minus 10. This is supposed to be your x. So now you can use the formula v squared equals u squared plus 2ax. So v squared is 20 squared, u squared is 0 squared, plus 2 into a is 5 into x. X is x final minus 10. So we get 400 equals 10x final minus 100. Agreed? Or minus 50. है 5 to 10
ये भी सही करा सर
standard correct only, right?
50 आंसर
So 10 xf equals 500 xf equals 50 meters. How many of you got the final position is 50 meters? You got it? You also got it? Did you actually get it in your notebook or you are just seeing the work on the board? Very good. What about Keshav? You got it in your notebook?
आंसर नॉट 50 it's 60
The
No.
answer is 40 plus
The answer is the answer 40.
so 40 so
X, I asked you what is his new position with respect to the lamp post. New position with respect to the lamp post is XF and XF is XI plus displacement. Okay, if I ask you what is his displacement, what would you? Displacement would be 40. Are you getting it? Read the question carefully. If they ask what is the displacement of the person during this time, it would be 40. Final position minus initial position, which is X. If they ask what is his final position, you have to say initial position plus displacement. Clear or not? Clear? Okay. How much time is left?
1 minute
1 minute. Sure. Okay, then we'll stop for now. Next class we'll start with projectile motion.